Okay, 7.5, last section of the chapter.
Oh.
Hypothesis, testing
Boring.
for population, variance, and standard deviation. What's the symbol for population variance again?
S.
Sigma squared. And population standard deviation. Sigma. Okay, the things to know here. They have to tell you that the population is normally distributed. Population must be given as normal. Your critical values that separate the shaded from the unshaded, do you remember what they were back in the last chapter? They were chi-squared values. So the critical values are the chi-square values. I did copy that table for you on a sheet, otherwise it's on page A21.
Did you get a haircut?
I trimmed my bangs this morning.
Looks nice.
Thanks. And then the formula we're going to use. The chi-square for your sample variance or sample standard deviation, the S squared or the S, the formula is n minus 1 times the S squared over the sigma squared. Okay, I think we can actually just go right into, oh, I better do that first.
Wait, how is that for both of them?
Because if they give you S squared, you just use it and don't re-square it. And if they give you S, you just take it and you square it. So it works for both of them. You'll see. Well, they're going to do one of each, where we start out with S squared and where we start out with S. So, all right, so the first example, we're just going to find our critical values. Find the chi-squared critical. And we're going to be doing 3 of these. So if the ha has a greater than, where is your shaded region going to be at? To the right. Remember the ha where it points. And these are the ones that are not normally distributed, but it doesn't matter if you make them normal. Shaded is in the right. If n is 18 and alpha is 1%, I want you to be able to find this chi-squared value off the table. So the 1% is here, 99% is here. If you look on your chi-squared table, what do we want to look up as far as area? Which one do I want to look at, the 99 or the 01?
99.
Chi-squared is area to the right. See how they've got it shaded to the, so you can look at the top. See how it's shaded to the right? This is your alpha. You want to look the alpha up, which is to the right. So in degrees of freedom is 1 less than the sample size. So 17 and the 01. 33.409 for those at home.
Time out.
Okay.
Wait, what?
Degrees of freedom.
Okay.
1 less than the sample size.
Okay.
So we're down to 17. And we always look up area to the right. Okay. And I forgot the number already.
33.409.
All right. If the ha has a less than, our shaded region to the left. This time we're going to let n equal 25 and alpha equal 0.5. So you know the shaded is the 0.5. Here the unshaded is the 9.5. If you want this chi-squared, which area are you going to use?
9.5.
The 9.5. I should probably circle it. 9.5 we're going to use here. The 0.1 we use here. Why those ones? Because they're to the right. You always look up the area to the right. So the book, we're going down to 24 degrees of freedom. 13.848. Good on that?
Yes, ma'am.
Okay. 13.848. And I think you can probably guess what's coming up next. So part C. What's my last option for the ha? Not equal to. Ah, what'd you say? Oh, yeah, you weren't close. Yeah, good try. Alpha is, let's go 19. Oh, sorry, sample size. The alpha is 0.5 again. N is 19. Okay, be careful here. So we have to find both critical values. So each shaded is going to be 0.025. That puts 95 in the middle. So to find this right chi-squared, what area are you going to look up? Austin, did you have a question? No? No?
0.95 plus the...
Well, I'm finding this one first. This one is just the 0.25 because that's the total to the right.
Oh, really?
And then the next one I'm going to do what you were doing. So 18 degrees of freedom. And then over to the 0.25, what are you coming up with? 31.526. Okay. To find this one, what area are you going to look up? 0.975. You got to add the 95 and the 2.5 together. That's the one you're going to use to find this one. And it should be smaller because remember the number line starts at 0 back here. 8 point what? 231. Okay, are you good with reading the chi-square table?
Yeah.
Everybody's comfortable with that? Okay, so now we hypothesis test. Oh, there's no by program. I forgot. We're just going to do one with variance and one with standard deviation.
There's no calculation?
There's no calculator program for the chi's. Well, we like that better? Okay. Okay, number 2. Claim. Gotta find it here, number 7, 5. Are you? Let's see, a bottling company claims that the variance of the amount of drink in the bottle is no more than 0.04. So claim. The variance is no more than 0.40. So what they're saying is their bottle filling machine is doing a nice job. You're not getting ripped off when you buy the bottle. A random sample of 31 bottles had a variance of 0.75. Test at 1%. Assume the population is normally distributed. So we go through the same 5-step process. Rewrite the claim first, but get the symbols right. So because this one is about variance, that's what's going to tell you to come to this chi-squared section of your card. What's our symbol for population variance? Sigma squared. No more than. Less than or equal to 0.40, making that the ho. Greater than 40 would be the ha. After that, you make your graph and you shade. Where am I shading? The right tail, because the ha says so. And remember, this starts at 0. Got my shaded region somewhere down here in the right tail. This is 1%. This is 99%. Which one of those are you going to use when you look it up in your table? The 01.
50.892.
If we believe her.
I'm gonna double check.
Okay, good call.
It is.
Oh, it's been verified.
Weird, huh?
Didn't throw you under the bus today.
Tried, but didn't.
Okay, now what's next? The formula. We need to take our sample and turn it into a chi-square. Where are you confused?
Are you looking at the table?
Yes, that's the table.
Oh, I was thinking of calculator.
So we're trying to see if our sample falls between 0 and 50 or after this 50 point to see where I'm at.
Okay.
So the sample, when I give you sample variance, what letter is attached to that?
S.
Says the girl. Nope. Sample variance. Sample now. Sample. S squared. This is
I was like halfway there.
S squared. That is S squared. It's already been S squared.
I told you.
So the formula to convert that S squared into a chi, I'll just write the formula so you have it. N minus 1 times S squared over sigma squared.
But we don't put it on the S squared or S squared.
So N, what's my N? 31. Minus 1.
Minus 1 all times 0.75.
0.75 is S squared. Do we agree? So we don't no need to square it again. And then over, do we know sigma squared?
I don't think so.
0.
0.40, sigma squared in the ho. And the ha. So don't square them again. They're already that thing squared. So we need a calculator crunching to happen.
Oh, you can do that. You can, because Matt isn't here today.
Yeah, Matt's not here today.
Well, that's where we all right. Yes, make the juniors.
Yeah, juniors are on it. 56. 0.25.
Betsy.
Another world heard from over there.
Yeah, I know, usually you only hear from me.
Yeah.
Hey, you wanna hear
Who
a
doesn't
good
hear
point?
from you? Let me throw that out there.
Reject the whole.
Yes, 56. 0, 50.8, 56.
Reject and hose.
Reject the hoe. What are you saying about the claim?
False.
Claim is false.
I mean, you can tell by just looking at the thing.
Okay, so we try one more. And we'll be
Hey,
done.
George, guess what?
What?
You know how you yell at me for always talking?
Yeah?
But you pretty much talk all day, so it's like.
Oh, yeah, but mine's like organized talking.
It's organized.
They're good like not talking to our class is kind of bad.
Yeah, you guys are bad that way. But they're not all here today though either.
Yeah,
They're only,
usually allowed.
So where's
this
the
little
good
group
class?
over here is usually what talks. See, and Alexis doesn't have anybody to talk to today.
Exactly.
What
So
about
yes,
chopped liver?
normally this group over here is the chit-chatty group.
Who's the squad?
Ah, the leaders are here.
You, Katie, and me, Lexi, Axel.
Yeah, that,
I'm just out of it.
yeah, you're not, you're, yeah,
Squad.
yep. Okay, claim.
You're pretty much as guilty as these ones.
Is that the standard deviation?
Screw that, no.
In the length of response times, this is the police department. He says the standard deviation of our response times is less than 3.7 minutes. Sample 9 response times. And you find that the standard deviation is 3.0.
Sample 9 what?
Times. Test at 5%. Population is normal. So again, it's all about what the claim is, what variable we're working with. And this time, we're claiming something about a standard deviation. So it's sigma. So your claim will have a sigma in it. That's going to tell you to come to this section on your note card and to use the chi's, not the z's, not the t's. There's 3 things to remember. Less than, I don't know, 3.7.
At least we don't have to take the exam.
That's 100% true.
I feel like that was correct.
Making the claim the ha.
Pretty sure he said that during econ too. No, econ's okay.
Yeah, can we?
There's the ho.
So you were never in that discussion.
Not even in
And where are we shading? Left. The ha says to the left.
Emily, shut up.
Okay.
Let's see, we got 05 and we've got 95.
Okay, so,
So which one are you going to use?
use the 9.5.
Good choice.
See, I told you, I know what I'm doing.
Well, let's perform now on the test.
Why is this thing just leaking? I haven't even tipped it over. It's just
Doing his thing. Just running away from you. Roast it.
Who's got it for us?
yeah.
Say again?
Dude, it's so hot.
2.733.
You're overriding our voices. Quit.
Yes, stop talking, we're almost done. Now the formula. The sample value is the standard deviation of 3.0. What letter is this?
What?
That is S, because it's a sample standard deviation. So that is just S.
So we have to square
We
it.
got squared.
So we're going to have to square it when we put it in the formula.
So is it 3 point?
So this chi-squared for 3.0 is going to be, do you want me to write the formula out again?
No.
No, so it's going to be 9 minus 1
8.
times 3.0, or just 3, squared over 3.7 squared. So the big difference, this time I have to square them because I gave you standard deviation. The other one we didn't square them because I gave you variances.
Got it. So standard deviation equals squared.
Good job, Kenny.
Never mind.
Yeah, let her work that out in her mind.
Yeah, don't mess me up.
Yeah, don't be speaking out loud like that.
Yeah.
Sorry. I'll try not to be so
My hair smells like a bonfire.
And what are we coming up with?
We have 5.56. That's
Fi-
what I got.
Okay. So where's 5.26 going to take us?
Fail to reject.
We gonna fail to reject that.
Yep. Failed to reject the hoe. Neat.
Beep, beep.
Okay.
Okay.
Your assignments for Monday. Stats.
Yeah, tomorrow's
We got prom, I got dances.
What do you
And then
think?
it's Mother's Day.
What do you think would be fair here?
Like two or three? 4.
I agree with 4.
Yeah, 4 is a good number. I agree with 3.
I had 4 down, 18 through 24 even.
But we should have bargained for.
I was just seeing, 'cause this is what I had, I didn't change it.
Hey, but let's take off one of the other.
I think 4 is reasonable.
Kenley, you're pushing.
Okay.
She's gonna add
Yeah,
one.
just do 3.
I'm just
We'll see how that
cranky,
goes.